This video is going to be the second of the two videos on autocorrelation. So let's run the regression. Make sure that labels are clicked and you have all the plots. Notice, like last time, there is an inverted U pattern. Last time it was a U shape, this time it's an inverted U. Notice we also have a heteroscedasticity problem because the errors are close together here and far apart here. So let's look at the data. Again, let's do a scatter plot. Insert, scatter. And generally you want to make the graphs bigger than they originally were. Notice this looks like a mountain. If you've ever seen an inverted x squared graph, this is what it looks like. If you have a U shape, it could be also x squared. This is a case where it looks like there's a relationship with the square. Again, like last time, if you were handing this in, you'd have to do all the labels. I am not going to do that to save time on the video. That's an earlier video. Well, if x squared is the problem, we need to add in a column. So I'm going to right click, insert, entire column. And we do price squared. This is going to equal that caret 2 means raised to the second power. You could also just do a2 times a2. Copy that down. One thing I just noticed, the original prices didn't have dollars. Doesn't matter because the new prices are, it's price squared, and that cannot have dollars because it's dollars squared. So now we run the regression. The data is over in column C. And here we could just eliminate the A and change it to a B and do regression 2. Let's look at the line fit plots and the residual plots. Notice no U-shaped pattern, no U-shaped pattern. Again, as a general rule, you want to make it bigger so you can see it better. And as I said before, we have a heteroscedasticity problem. That's a different video. We take this, line fit, pretty good. It's above and below. Oops. Make this one bigger. Again, it's both above and below. In both of these cases, you can see heteroscedasticity problem because it goes above and below farther at the end and at the beginning. When you have a square term, it's often common that you have a heteroscedasticity problem. In this case, we would probably want to test for heteroscedasticity as well. If we go back to the original regression, if you see both problems, do the test for the x squared. So you square whichever variable gives you that pattern. If we compared the end results, significance of f had e to the negative 40 and was 0.915. It's now e to the negative 60 and 0.977, much better fit. Price is no longer significant. It had been highly significant. But if you look at price square is much more significant than, no, actually it was less significant than there. Why is this? Well, again, we're trying to fit a straight line through a curve.